Law of cosines. Suppose a boat leaves port, travels 10 miles, turns 20 degrees, and travels another 8 miles. How far from port is the boat? Unfortunately, while the law of sines lets us address many non-right triangle cases, it does not allow us to address triangles where the one known angle is included between two known sides, which means it is not a corresponding angle for a known side. For this, we need another tool. Given an arbitrary non-right triangle, we can drop an altitude, which we temporarily label h, to create two right triangles. We will divide the base b into two pieces, one of which we'll temporarily label x. From this picture, we can establish the right triangle relationship. Cosine of alpha equals x divided by c, or equivalently, x equals c cosine of alpha. Using the Pythagorean Theorem, we can establish b minus x squared plus h squared equals a squared, and x squared plus h squared equals c squared. Both of these equations can be solved for h squared. H squared equals a squared minus b minus x squared, and h squared equals c squared minus x squared. Since the left side of each equation is h squared, the right sides must be equal. C squared minus x squared equals a squared minus b minus x squared. C squared minus x squared equals a squared minus b squared minus 2bx plus x squared. C squared minus x squared equals a squared minus b squared plus 2bx minus x squared. C squared equals a squared minus b squared plus 2bx. A squared equals c squared plus b squared minus 2bx. A squared equals c squared plus b squared minus 2bc cosine of alpha. This result is called the law of cosines. Depending upon which side we drop the altitude down from, we could have established this relationship using any of the angles. The important thing to note is that the right side of the equation involves an angle in the sides adjacent to that angle. The left side of the equation involves the side opposite that angle. Law of cosines. Given a triangle with angles and opposite sides labeled as shown, a squared equals c squared plus b squared minus 2bc cosine of alpha. B squared equals a squared plus c squared minus 2ac cosine of beta. C squared equals a squared plus b squared minus 2ab cosine of gamma. Notice that if one of the angles of the triangle is 90 degrees, cosine of 90 degrees equals 0, so the formula c squared equals a squared plus b squared minus 2ab cosine of 90 degrees simplifies to c squared equals a squared plus b squared. You should recognize this as the Pythagorean Theorem. Indeed, the law of cosines is sometimes called the Generalized Pythagorean Theorem, since it extends the Pythagorean Theorem to non-right triangles. Example 6. Returning to our question from earlier, suppose a boat leaves port, travels 10 miles, turns 20 degrees, and travels another 8 miles. How far from port is the boat? The boat turned 20 degrees, so the obtuse angle of the non-right triangle shown in the picture is the supplemental angle 180 degrees minus 20 degrees equals 160 degrees. With this, we can utilize the law of cosines to find the missing side of the obtuse triangle, the distance from the boat to port. X squared equals 8 squared plus 10 squared minus 2 multiplied by 8 multiplied by 10, cosine of 160 degrees. Evaluate the cosine and simplify. X squared equals 314.3508. Square root both sides. X equals the square root of 314.3508 equals 17.730. The boat is 17.73 miles from port. Example 7. Find the unknown side and angles of this triangle. Notice that we don't have both pieces of any side angle pair, so the law of sines would not work for this triangle. Since we have the angle included between the two known sides, we can turn to law of cosines. Since the left side of any of the law of cosines equations involves the side opposite the known angle, the left side in this situation will involve the side x. The other two sides can be used in either order. X squared equals 10 squared plus 12 squared minus 2 multiplied by 10 multiplied by 12 cosine of 30 degrees. Evaluate the cosine. X squared equals 10 squared plus 12 squared minus 2 multiplied by 10 multiplied by 12 multiplied by the square root of 3 divided by 2. Simplify. X squared equals 244 minus 120 multiplied by the square root of 3. Take the square root. X equals the square root of 244 minus 120 multiplied by the square root of 3, which is approximately 6.013. Now that we know an angle and its corresponding side, we can use the law of sines to fill in the remaining angles of the triangle. Solving for angle theta, sine of 30 degrees divided by 6.013 equals sine of theta divided by 10. Use the inverse sine. Theta equals sine inverse of 10 sine of 30 degrees divided by 6.013, which is approximately 56.256 degrees. The other possibility for theta would be theta equals 180 degrees minus 56.256 degrees equals 123.744 degrees. In the original picture, theta is an acute angle, so 123.744 degrees doesn't make sense if we assume the picture is drawn to scale. Proceeding with theta equals 56.256 degrees, we can then find the third angle of the triangle. Phi equals 180 degrees minus 30 degrees minus 56.256 degrees equals 93.744 degrees. Example 8. Solve for the angle alpha in the triangle shown. Using the law of cosines, 20 squared equals 18 squared plus 25 squared minus 2 multiplied by 18 multiplied by 25, cosine of alpha. Simplify. 400 equals 949 minus 900 cosine of alpha. Negative 549 equals negative 900 cosine of alpha. Negative 549 divided by negative 900 equals cosine of alpha. Alpha equals cosine inverse of negative 549 divided by negative 900, which is approximately 52.410 degrees. Notice that since the inverse cosine can return any angle between 0 and 180 degrees, there will not be any ambiguous cases when using law of cosines to find an angle. Example 9. On many cell phones with GPS, an approximate location can be given before the GPS signal is received. This is done by a process called triangulation, which works by using the distance from two known points. Suppose there are two cell phone towers within range of you, located 6,000 feet apart along a straight highway that runs east to west, and you know you are north of the highway. Based on the signal delay, it can be determined you are 5,050 feet from the first tower and 2,420 feet from the second. Determine your position north and east of the first tower and to determine how far you are from the highway. For simplicity, we start by drawing a picture and labeling our given information. Using the law of cosines, we can solve for the angle theta. 2,420 squared equals 6,000 squared plus 5,050 squared minus 2 multiplied by 5,050 multiplied by 6,000 cosine of theta. Theta equals cosine inverse of 0.9183 equals 23.328 degrees. Using this angle, we could then use right triangles to find the position of the cell phone relative to the western tower. Cosine of 23.328 degrees equals x divided by 5,050. y equals 5,050 sine of 23.328 degrees, approximately 1,999.8 feet.